All right, now we're going to do an example. We have this system of equations here. And so we're going to set the coefficient matrix, right? So we're going to set it up where we have AX is equal to B. So that's going to be our A matrix is our coefficient matrix. So it's going to be, in this case, 1, 3, 0. And then 1, 1, negative 2. And then negative 3, 5. And then our X matrix is just our variable column matrix of variables. So it's X, Y, and Z. So this is just going to be X, Y, and Z. And that's going to be equal to our column matrix of constants, which is going to be negative 10, negative 4, and 11. All right, now we just need to find the inverse of this, right? And I think did we do something, hold on, did we do do we see this one before? Yes. Yeah, this is the same. This is the one that we did before, and we found the inverse of this one. Let me look it up here, because we found that in a previous example. Okay, so let's see. Oops. All right, so it was negative 1/2, negative 15 halves, negative 3. So this will be, so we can go to here because we already made the inverse. So X, Y, and Z is going to equal, now the inverse here was negative 1/2, negative 15 halves, negative 3, followed by 1/2, 5 halves, 1. And you should have this in your notes from the previous example. And then 0, negative 3, negative 1. All right, so this was our inverse. So we found the inverse of this one. So now we can use the inverse here because remember, this gives us X is equal to A inverse times B, right? And so now we're going to take negative 10, negative 4, and 11. So now what I'm going to do is to solve for X, Y, and Z. This is going to give us a 3 by 1 matrix, right? So this is going to give us another column matrix. So all I'm going to do is go across the row. So negative 1/2 of 10 is 5. Negative 10 is 5. And then negative 15 halves times 4, which is negative 15 halves times negative 4 is going to be 30. So far we're at 35. 35 minus 33 is 2. Okay? So now I'm going to do it again. So this is now positive. So this is now going to give me negative 5 minus negative 10, which is negative 15, and then negative 15 plus 11 is -4. Right? So all I'm doing is doing the inner product, right? So 1/2 times -10 is 5, plus 5/2 times -4 is -10, which gives me -15, plus 11, which is -4. Now I'm going to do the final one, which is going to be what? 0 times -10 is 0. -3 times -4 is 12. Plus 11 is 23. And so what this means is that x is equal to 2, y is equal to -4, and z is equal to 23. Now, the way you would check this is plug in. One way is to plug in 2, -4, and 23 to see if you get the same thing. So if I put in 2, yeah, 2 plus -12 gives me -10. That's correct. If I put in 2 and -4, that gives me -2. Hold on, that didn't work. Hold on a second here. Did I mess up? Or maybe I'm thinking, 2, 2, 2, -2. Oh, I'm sorry. Yeah, that's right, hold on. 2, so that worked for that one. 2, 4, so 2, -4, -2, and then 6. Oh, I did something wrong. Hold on a second here. Let me go back. So that gives me 5. Plus 30 is 35. 35. 35 minus 33. Okay. And then 1/2, that's going to be -5. -5, that gives me -10. -15 plus 11 is -4. Oh, I must have made a mistake here then. 0, 12, 0, 12. Oh, hold on a second. Yeah. 0, 12, and 11. And 12 and 11 is 23. What am I doing wrong here? Two, -4. Oh, wait a minute. Hold on a second. Did I write that down wrong? Oh, that should be a -1. That's, of course, that should be a -1. Oh, okay, so that, yeah, okay, now that makes sense. Okay, so that should be 12, 12 minus 11, which would be 1. Oh, okay, now that makes sense. Okay, so that means, yes, now it makes sense. So this would be 2 plus -4, which is -2, and then this would be -2, so that'd be -4. Good. And then of course this would be -6 plus 12, which is 6, plus is 11. All right, so it worked out. See? Good way to check things because you might have made a mistake writing down like I did. So it's always good to double check your work, make sure that it all works out. So in this case, it did. All right, cool.